API tokens, passwords, sensitive credentials, they're the keys to your digital kingdom, and if they fall in the wrong hands, the consequences can be devastating. Today, we're tackling this critical challenge head on. Kareem Iskander joins us to explore how to safeguard your most valuable secrets using HashiCorp Vault, showing us exactly how to protect your applications from exposure. My name's Kyle Winters, and this is Security Unlocked. Kareem, thank you so much for being on the show today.
Thanks for having me, Kyle.
During my time working in application security, I learned a lot about the importance of keeping your secrets safe. But for those who are not familiar, why is it so critical for developers and organizations today to secure their API tokens and other sensitive credentials?
It's just like anything, right? If you think it's important not to share out your username and password to the public, and if you think that that password should not be shared, the same logic applies to APIs. APIs are kind of a door into your application to pull data and sometimes sensitive data. And there needs to be a way to secure those APIs token. One of the things that as you're developing, and I'm sure you're aware of this, Kyle, as you're developing applications, you're hitting different endpoints. You could be hitting a RESTful API. Maybe you have some type of device that you have an SSH key into, and maybe you have a username and password that you're authenticating using basic auth. And all of that, when you're building your application, what ends up happening is it creates this like secret sprawl. And as good developers, we got to make sure that the all of our secrets, everything that I just mentioned, are actually secure, and they are contained in a place where it's really, really hard to get into, just like anything, we do from an authentication perspective.
And you mentioned SSH keys as well. Many people think, secrets in this context is simply just usernames and passwords, but it goes beyond that. I mean, what are some other types that you've seen? I've seen plenty just in public GitHub repositories on its own, but I know it goes beyond just passwords and API tokens as an example.
I've seen a lot, but the main things that I've seen that are an authentication method is the username and password. Some basic auth. You have your username and password assigned to you. You go grab a token and do something with it, right? That's how you authenticate. And via basic auth, you've got the regular bearer token that we're used to. And I've seen SSH keys. I've also seen private keys that are provided. And these are really, really important to keep them secure and keep them safe and isolate them from the application itself. So you need to have that kind of isolation mechanism for multiple reasons. And we can talk a lot more about the reasons why you need to isolate your tokens and everything from your application.
Yeah, I think a lot of developers, as they start building their applications or whatever it may be, convenience is what they're thinking of first when they're building these things. But security oftentimes is considered an afterthought, but it shouldn't be.
It's not.
And I think building in tools and mechanisms into it to ensure that you're securing your data from the beginning is important. So what types of tools are out there that can help keep your secrets secure?
Yeah, it depends on what kind of shop you have and you are. One of the things that I really enjoy using is Terraform when I'm building and standing up infrastructure and destroying infrastructure. And HashiCorp developed the Terraform tool. Cisco has a bunch of Terraform providers out there from the different products. Similarly, Hashi has come up with Vault. Vault is essentially exactly what it sounds, a vault for your secrets. And the secrets are everything that we just talked about. Vault is something that I use regularly when I'm developing applications, building demo, just to have a peace of mind where I don't have to keep my tokens in a Word file or in some text file somewhere. And also, as I'm building these different applications within Vault, I want to be able to kind of isolate, control which application has access to what API tokens or secrets or password, right? And Vault allows me to apply ACLs, access control lists, to the different secrets. So, which is really, really useful and powerful. So Vault, and I think we're going to get into a little bit deeper into how we do all of this. Vault by Hashi is an example. I know there's Ansible Vault as well. If you're an Ansible shop, it really integrates with automations from an Ansible perspective, where you can bring in that service into kind of like building that pipeline.
That's awesome. I'm definitely curious more about these ACL policies. I think it's important to make sure that the applications that you're working with can only access the secrets that they really need. So I'm curious if you could maybe show us a little bit of these ACL policies and just a general walkthrough of what the typical workflow is using HashiCorp Vault.
Yeah, for sure. So ACLs are really important concept and into Vault, because let's say you have four applications. These four applications have access to different API endpoints, but also they share access to the same API endpoint. Now, if one of these applications, and the applications do different things, they're not part of the same flow, workflow. But if imagine application one gets compromised, and you still have application two, three, and four running, and you realize that the entry point for application one is an API token that's not shared. If you don't have an abstraction layer for your tokens and your secrets, you're gonna have to go change every single token, every single username, password to stop the attack that's happening on your application. But if you have ACLs where you're saying application one has only access to these three sets, I can simply say deny access to that token and for application one, and without compromising application two, three, and four, without having them stop, and it would not affect my business. And so this is why it's really important to do that. Here is an initialized developer server of Vault that I'm running on my local system. And the way that you get this rolling is you start up, you install Vault. You go to your terminal, you say vault server -dev, and that would basically initialize run Vault in development environment. When you're running it in a development environment, the secrets and everything that you save are not persistent. And so as soon as you kill that instance, you've lost everything that you've saved in. There are other ways that you can deploy and run Vault. Obviously, it's production ready, it's enterprise ready, so you can have redundancy and all of that, but I'm not going to dig into that. We're talking about not really how to get started with Vault, but how to bring it into your security kind of workflow while you're building applications. So there are a couple of things. If you look at Vault, now I stood up a development environment here, and before you do anything, you need to initialize Vault. And there are a couple ways to initialize it. You can go to the GUI, like what you're looking on my screen here, and initialize it. Since I do a lot of demos and Vault itself has really good APIs, I ran a simple Postman flow here that allows me to basically initialize any instance of Vault that I have. First, you go in and you say, hey, this is my Vault server. It's on this local host, this IP address, and I'm going to initialize it. That's going to provide you with an unsealed token. Now, and I want you to think of Vault this way. If you have a physical Vault in your house, first thing you got to do is you got to figure out the key, the numbers to get into it, unseal it, open it, and be able to get into your precious items, right?
Really good analogy. It just makes it kind of hits home in terms of the perspective here. And even as an attacker trying to kind of crack into that, thinking of it as a vault in a literal sense is very valuable.
That kind of how I visualize it, and it makes sense to me when I see it this way. But you essentially go in and you say, I'm initializing is going to give you an unseal key. And with that, you want to go in and say, okay, now that I have the unseal token, I want to unseal the Vault and then enable some engines and engines in secret engines. So Vault itself supports multiple secret engines. There is key value pair version 1, there's key value pair version 2. It's basically that key value pair. It's a JSON string that you push out to Vault that has the secrets. This is my username is X and my password is Y. And then if you're using version 2 of key value pair or KV v2, it allows you to keep history as well. So that's the kind of the minor differences between V1 and V2, but there's plenty, right? If I'm looking at the GUI here, I can enable multiple engines. I can enable things like API, AWS access. I can, SSH is one of the things that we talked about, certificates that we talked about as well. And you can see from a generic cloud and infra, the different engines that it supports.
That's awesome to see all the typical public cloud providers on there as well, and just lots of different options. So this definitely gets like my brain thinking about different things that I can store inside of here.
Exactly, but we're developers and we're talking about application development here in a sense. So what we care about is key value pair because it's a JSON. It's something that we're familiar with. We can just push this out and set it and forget it. But before we do that, we got to start creating a role for the application itself. And this is essentially how it works. You create an app role. That application role is assigned to the application that you want access to the mount. So each application will have access to a mount, and think of mount in Vault terms as a directory. So, my Catalyst Center application has access to Cisco U / DNAC or Cat Center, right? My Meraki application has access to /Cisco U / Meraki. And they are separate app roles with separate access to the different mounts. Once I've created an app role from that point, then I can go and say, this application role has access to only this mount and with this token. And then I can assign this policy and app role to bind them together, right? And then assign it to my application. Then I'll get a specific token for my application that will give me access to whatever secrets are in this. And then as a user, I could start writing also secrets if I'm given create, update, or read access to this mount. And this is essentially part of the initialization process of Vault. Once we have all of that in place and done, then I can simply say, okay, I have a client token, and this is how the steps to generate a client token that's been assigned the right ACL. That token I can provide to the application, and then I can go start coding. In this case, I'm very simple use case. I access Catalyst Center with a Catalyst Center. If you're familiar with it, the way that it works from an authentication perspective, you're given a username and password. You authenticate with basic auth from there, and then you get a token. That token is valid for, 2 hours, something like that. I can't remember exactly, but that token is valid. Then that's how you start accessing the Catalyst Center APIs. So with that, I went ahead and in the application, in the mount that was given to my application, access to the mount that was given to my application, which if you notice here, this is what it's called, sandbox, /devnet DNAC SB1. I wrote the username and password and the URL as a key value pair into Vault. And it's okay for me to share this information. This is public sandboxes that anybody has access to via DevNet. So I'm not breaking any rules here.
Yeah, I don't want a video about protecting secrets to expose actual secrets.
Exactly, right?
So I'm glad that you called that out.
That would be super ironic. So now that we have that, it's been saved in my mount, and you can see now I can programmatically via the APIs get that information. And so now that it's available programmatically, I can actually go and code it. I can write a script, I can put it in Terraform, whatever it is that I'm trying to do, right? I wrote a simple script just to showcase how all of this is put together, leveraging, which by the way, this is something for developers. If you're looking to incorporate Vault into your security workflow, they have a really good SDK called HVAC. They being HashiCorp Vault itself has an HVAC. It's called HVAC.
Yeah, that's really good because I instead of writing out all the individual API calls, I'm seeing less than 20 lines of code here, and 6 of those are just the import statements. So it looks like that is a very valuable SDK.
Yeah, it's very useful and it's very logical too. So all I'm doing here is I'm defining the server. And I'm instantiating a client. So the client is going to live here and it's going to connect to the Vault server that's running locally. It needs 2 pieces of information that we've built to initialize. Before you do anything, you got to check if the Vault is sealed or not, right? Before you get into it, we talked about that. And then the client token with the right access, provide that to my application. And then the mount point, and the path, which is provided by my Vault admin that this application has access to. right? So that's all the information I need. And I go in and check, hey, first thing, is my vault sealed? If it's sealed, unseal it. But typically, most vaults after initialization are just in an unsealed state because they're there to be a service to other applications. And from this point on, I can just simply say, okay, it's unsealed, I'm good. Go with my client token, given the amount, pull the information that I need to authenticate against Catalyst. And this is where I grab the auth that I showed you in the last API call. It comes back as a JSON for me. So I iterate through it and I pull in the username and password. And without getting into too much details on how Catalyst Center authenticates, because this is and how Catalyst Center APIs work, because this is about security, not really about how to do all of that. I have a simple script, a simple function here that goes and pulls a list of devices that my Catalyst Center controller is managing. And if I run this, you can see a couple of things. First of all, I printed it out for the audience to just see what's happening. I have all the secrets here that was pulled from my Vault instance. This was entered by me in the mount when I was initializing, right? So now it's part of my application. I have access to it, which I can go simply say, okay, now I'm gonna authenticate against Catalyst Center. Catalyst Center came back and authenticated successfully and gave me a token. And with that token, now I can go in and call the different API endpoints to pull the different list of devices. So you can see how really useful this is. The one thing that you need to notice is there's no tokens whatsoever in my application.
Yeah.
There's no API keys. There's no config file attached to this that has my access to the infrastructure. All I have is environment variables with the unsealed key, which you typically don't need, but just the environment variable for a client token that's provided by Vault, and everything else is just interactions via secure APIs.
So this is awesome, Kareem, and it seems very easy to do. It seems like there's no reason why people should be pushing commits now that have these hard-coded secrets in them. If I'm somebody who wants to implement this, where can I go to find more information and learn about how to do this?
I wrote an entire tutorial around the steps that we just talked about, step by step how to get started. I also have this code and all the code that's available to initialize your instance of Vault locally. I have that part of the GitHub repo, and it's mentioned in that tutorial. So I think the best way to get started with all of this is watch this video. Check out u.cisco.com. I'm sure we'll put the link here for that specific tutorial there. Clone the code that's on our GitHub repo and get started.
Awesome. I'm looking forward to going through it myself. Kareem, really appreciate you being on the episode today. Thank you again so much.
Thanks for having me, Kyle. It's always a pleasure.
See you all soon.